Hi everyone and welcome to my new video. In this video I'm gonna be showing one interesting device that I did. So firstly I'm gonna say a couple of words and let you know what the device does. After that I'm gonna show you how exactly I did it, what are the connections, so you can make the same thing if you like. And after that I'm gonna implement this device in a real life scenario where you will see how it actually works. So this device can detect movement. So okay, there are a lot of devices out there that are vastly available that can detect movement, like Pure Sensor and so on. But this device works a little bit different to the other that we normally see on the shelves. And this device can detect movement using microwaves. So how it actually works, it sends microwave and emits microwave signals. It uses Doppler effect. Basically, when a movement happens, the bounce frequency of the signal gets a little bit changed, and this device detects that and triggers something. That's the main difference. What's also good about this device is that it can detect movement through walls, to thin walls, and through glass, through door, through wood, which makes this device really interesting because the other ways of detecting movement is not that powerful to go through the walls, for example. Microwaves signals go through walls, and this device can detect movement. The device emits signal at 3.2 gigahertz. I'm gonna let you know how I used the device, and maybe you can just replicate or maybe change something that you think that is interesting to be tried. Let's open it. On top of it is the main device, or the device that can detect movement. The name of the device will be written somewhere here. So it is basically a microwave sensor, how I said before. So let's see the connections. On this device, we have a ground, which can be connected to the ground of the battery or with the other device's ground. We've got out pin, which is the pin that gets high when the device catches a movement. We have VIN pin, which is the voltage input. The voltage input here, we have a lot of freedom because we can use this device to power this device. We can use 4 volts up to 28, I guess. And this is the CDC pin, which can be used in order to connect a photoresistor. Here are the other connections. Basically, it's pretty simple. We have 5 volts converter in order to convert the battery voltage into 5 volts, which I need for the rest of the circuit. Basically, we have the plus of the battery through this connected and the minus that go through these pins, which are input minus, input plus, and these are the out pins. Here I have 5 volts. All components will be listed down below, so you can buy them if you like. I have connections here for like common connections, and I've got a relay. So the relay has normally voltage input, which is connected directly to the 5 volts, and I've got ground, which is connected to the common ground that I've got here. And the input pin is connected through this little, I would say, adjustment that I did. Why? Because this device outputs a 3.3 volts signal when it detects a movement, but I didn't have a relay that is active high. This relay is active low, and that's why I use an optocoupler in order to convert the output high into output low signal. Basically, this device turns on the optocoupler, and optocoupler then sends the ground directly to the relay, and it works. So let's close it up. What's also good, I tested it. It can detect movement up to 7-8 meters, which also is something interesting. So let's see how it is gonna work in a real life scenario. So let's get started. And here it is. I implemented the device, and it is pretty simple how it actually works. As you saw on the bench, when the relay gets turned on, just so how it works. So just when the relay turns on through these wires, I'm gonna hide the wire behind the door, and through these wires it just connects this tester here, which is part of an already created system which has been working for more than, I don't know, 20 years. It's got its own timer relay and so on. So my system is pretty basic. When the microwave sensor detects a signal, it turns on the relay, and the relay connects just this tester, which makes pretty simple, beginner friendly, I would say. We are gonna be waiting until the next turn off of the light and see how it is gonna work. I'm gonna make a movement, and here it is. I just made a movement and the device was turned on. So my device was turned on, which connected the tester that was already here. After almost 1 month of using this device, I made 2 changes that I want to share with you. So firstly, I reallocated the sensor from here to here. The reason was because whenever someone was going through this place here behind the door, the sensor used to activate itself. The reason is because the waves can go through the door, like we mentioned, and I relocated above this frame here, which is a metal frame on the door, and the waves cannot go through the metal, and now it works without issues. The next change that I did, I changed it from battery usage directly to 5 volts. I added an AC to DC converter here, and I connected it directly to 5 volts. Like every project, it is a small project, it's a pretty easy project, but there can be changes and improvements, and I want to share them with you. So if you're planning to use this kind of sensor, it can be beneficial to plan your place, to see whether you can run on batteries. Definitely you cannot run on batteries because it drains almost 5 milliamps on average with the other equipment, with the other components, and it is definitely not something that you can run on batteries because you need to change the batteries or recharge them. So it is definitely a good idea to have a stable 5 volts in order to run the sensor and the other components. So thank you for watching. If you like these types of videos where I'm talking about electronics, programming microcontrollers, or everything related to technology, please consider subscribing to my channel. It means a lot to me. So thank you and bye-bye.